Okay, so for today's discussion class, it's a new topic, no, but it's still continuation of our transfer function. Nakastart na ba tag transfer function class? Hello, can you hear me?
Yes.
Hindi ko kadungog niya. Wait lang. Okay, nakastart na ta og transfer function.
Wala pa, miss.
Wala pa ta ka-start og transfer function. Okay. Mm, dili ta ka-start. Okay. So abi na ko naka-start na ta. Okay, so let me pull up my FCS. FCS or I don't know. FCS. Mm-hmm. Copy, paste, edit. Okay. By the way, class, I will be returning your paper. Dungan na lang siguro sa inyong sa inyong midterm nga paper if dili jud ko kahatag. Okay, because next week is intrams. So basically, depende sa mga nhi. Okay, but I want to return the paper as a class sa inyong nga class naman. So maybe after intrams, but busy na taong discuss ana for the coverage of our midterm. Kay supposed to be midterm is after the first week of November. But naaman tay intrams, so ma-move ang ato ang midterm exams. So extend lang ko ana og 1 week for topics, new topics to be discussed for the coverage of our midterm. And after that week, then we can have our midterm exam mo, 'di ba dali ra kayo. Kung di makaya extend pa yun. Okay. Ay naku klase akong choppy ko kay hinay ang signal. Okay. Hmm, okay. Let's start for our transfer function no. So if you're a given system, okay, a simple system given R, okay, RT as our input, and we have a system HT, okay, this is our system, and YT as the denotation for our output. Okay, now through this one, we can have a system YT by multiplying our input through our process inside that system. Okay, from that, now by convolution property, to make it on a last Laplace form, so that's y over s, okay, kaba naman tana, y over s, rs times h of s. Okay, in that form, we can have our system HS, which is y over s all over rs. Okay, that's the simple transfer function definition for a simple system. If we have a closed loop system given Rs as our input, okay, and we have a negative feedback na summing junction, okay, bati siya. It's negative and this is positive, okay, and we have a gain, okay, G and a CS output. Then we have a feedback H, okay, a closed loop has a feedback and back to our summing junction. Okay. Now, if we have this kind of system class to find our CS, okay, to find our CS, okay, abot, di mo kita sa akong cursor, okay, ig, um, RS, musod siya sa ato ang summing junction, musod siya og open loop gain, you can have our output. Now, every closed loop system class na atay feedback. So, after that CS, di ba magtutuyok man na ato ang system, atong process. Now, that CS will go through our H. Di ba? Mudagan na po na siya sa atong feedback. Okay? Naigabot sa itong feedback through convolution property, you can have HCS. Right? Igabot ni HCS, after ana iyang output, musod na po na ito ang summing junction or our junction generally. And it is on negative form or negative feedback na junction. So this is RS, naman tayo RS from here. Right? Natay RS from here. Now, additional lang pa sa diri, okay, nga output, okay, additional sa atong output, so that's minus, oops, because it's on negative feedback, okay, RS minus HC of S, okay, because HC of S, nidagan man siya pa doon diri, plus naapa jud siya punan siya ni RS pero dili siya add, it's not minus because it's on negative feedback. If you're using positive feedback, okay, that's plus, okay, that's RS minus HCS, okay. Now, having this, our new output, okay, C of S is our RS, RS minus HC of S i-times sa ato ang G, okay? Because moagi man siya G, agi siya sa atong gain. A system has its gain. So that's R of S minus HC of S. Multiply this whole new output with G. Muna siya atong moabot sa C of S nga bag-o. Okay, now simplifying that one, we have R of SG minus HGC of S. Okay, so getting the RS, so that's C of S plus HGC of S. Okay, now our transfer function class T, okay, that's the general term sa ha, but in our system it is CS over RS because it is the ratio of our output to our input. So our output is CS, ratio sa atong input, that is RS. So CS over RS. Now CS class is in here, right? We need to have our CS. How? Okay. Now given RS equals G, RSG equals CS plus HGC of S. Can you still hear me?
Yes, ma'am.
Okay. Okay, given that one class, we can factor out CS from here. 'Di ba si CS is common. So that's 1 plus HG, right? Then we can have this equals to ako na isulat RSG. Then from this part on, we can have our RS over CS. Okay, from this, okay, we can have our CS over RS, okay? CCS kuhaan og 1 plus HG. So basically, 1 plus HG is our denominator. Okay? And RS kuhaan og G. So that's G. Okay, kung imo na i-cross multiply, okay, that's GRS. And that's 1 plus HGCS. Okay? Or you can do manual subtraction to have the final transfer function. 1 plus HG. Kani siya nga G class, it's a gain. Ha? Dili na siya conductance. G as gain na siya. Gain. You can use denotation A, di ba? From our gain in mixed signals, it is denoted by letter A. In here, letter G lang siya. Based sa textbook nga akong gikuhaan. Okay. So far, nakasabot ra ba?
Question lang man ba?
Yes.
Unsa gina unsay unsay name na CS ug RS ug H ma'am?
H is our feedback. That's the denotation. Kay mo na hatag nga ang pangalan sa iya ha. In this presentation lang here. Okay? In this presentation. You can have feedback F. Okay? Si H lang is iyang gibutang. That's the feedback. Now G is our gain. You can have letter A also. Okay? You can put that. Basta consistent lang ka. CS is the denotation for our output. RS is for our input. You can put input as X, output as Y. Okay? Denotation na siya class.
Ang kanang
Placeholder
Y
lang
ma'am.
siya. Y. This one, this is, muna siya ang representation sa kaninga system. If we will put this the same with our kaninga system, I can have this as our R of T, C of T, and our H of T. So kung ato na himuon og um like this, so that should be C of T, R of T times our process inside the system or our system itself, C of T. So basically we can have C of S equals to R R of S times our H of S. Getting our H of S, so that's CS over RS. It's basically the same here. Ang diri, iya lang gidenotate is letter T, which is a transfer function, letter T. From the transfer function nga name in here, from our system, since system man siya, so that's H of S.
Okay ma'am, thank you.
Okay. So in here, okay, so transfer function, its definition, transfer function of control system is defined as, maklaro ra ba o gamay ra? Okay. Transfer function of a control system is defined as the ratio of Laplace transform of output response to the Laplace transform of the input, assuming all initial conditions to be zero. The function will also allow us to algebraically combine mathematical representations of some systems to yield a total system representation. Writing it in general order linear time invariant differential equation or LTI. So if we have an d raised to the power of n ct over dtn raised to the power of n rather plus an minus 1 dn minus 1 ct over dt raised to the power of n minus 1 and so on and so forth equal to b sub m d raised to the power of m rt over dt raised to the power of m plus bm minus 1 dm minus 1 rt all over dt m minus 1, and so on and so forth, given that our CT is the output and our RT is the input. Now, taking the A sub I, and B sub I of this for full equation, the form of the differential equation represent the system. Taking the Laplace transform of both sides, okay, this one class, the Laplace transform of this one, okay, is in this form, a n s n c s. This one is for this one, and so on and so forth. Now, for the right side of our equation, this is the equivalent Laplace transform. This is also the equivalent Laplace transform of our second term, and so on and so forth. It's basically the same for our differential solution. What they call that? I think that's differential Laplace transform solution of a differential equation. Do you still remember? Um, di ba apil mo na sa inyong exam? You still remember it? If you are given, for example lang no, if you are given um 2 d squared y over dt squared plus 12 dy over dt plus 12y equal to um ibutan na nato 3. Okay, 3 something. Okay, let me just express this in this order. So if we have it in general nth order linear time invariant differential equation, if we have 2d squared y over dt squared, it's basically the same for this one. The Laplace transform for this one class is 2. This is since this is naka squared, so 2s squared. So that's y of s. Remember? So this is basically the same. Okay, a sub n. Okay, this is for our coefficient, and the s raised to the power of n, it depends on what order is our differential equation is. Then c of s is the denotation nga niagi siya og Laplace transform. And a n minus 1 because it is on decreasing order. Okay, so a n minus 1, okay, that's the coefficient still, depende sa iya ha. Okay, so that's dy over dt, and s because it's on first order. So S ra siya, C of S. The same goes with our right side of our equation. So if you're given BM, DMRT over DTM, so you get the BM, you retain the BM class, and then you put S kung naka third degree siya, third order rather, so that's S cubed. Kung naka second order, that's S squared. It's on first order, just like this one. So it's just S. Do not forget the R of S since we are dealing involving R of T here, so that's R of S. Okay, and you follow the entire left and right equation. So if we assume that all in initial conditions are 0, so it produces this one. Okay, after nimo gikuha tanan nga Laplace transform class, imo gi-common si CS. Okay, i-common nimo si CS. So basically CS is this one. After nimo i-common and so on and so forth. Now for RS, gi-common sa nimo siya after nimo gikuha ang Laplace transfer for each term. And so on and so forth. Now, getting the CS over RS, you just need to ratio it. So our CS over RS is our GS. Some textbook class, okay, which is common. GS is the denotation for our transfer function. Some of the textbook uses H of S, and some uses just letter T. But with this one, okay, ang kuha ani is G of S, which is akong gikuan ani is unsa ito atong book, nice. Ka nice nga book. Okay. So getting our ratio, of our output Laplace transform to our input Laplace transform CS over RS, which is just equal to our transfer function G of S. It's just BM. Okay. You manipulate the equation to get the CS over RS. This is the um, solution. So this separates the output CS, the input RS, and the system. The ratio of polynomial is in S is on the right. So we call this ratio GS the transfer function and evaluate it with zero initial conditions. The transfer function can be represented as a block diagram with the input to the left and the output to the right. And the system transfer function inside the block is this one. So if we have our RS input in Laplace form and CS output in Laplace transform, this is our system. Mo na moagi nga solution or calculation inside our system, this one. Okay, so far, naka-follow ra. Cass, are you still there?
Yes, ma'am. Yes, miss.
Okay, so in here, we have the transfer function represented by dct over dt plus 2ct equals to rt. So if we take the Laplace transform of both sides, so basically, this is of first order man class. This one. This is of first order. So S na siya. And do not forget the C of S plus 2. We don't have any differentials there. Sorry. So you just copy the C of S. And on the right side of the equation, we don't have any differentials as well. So that's R of S. Okay. Now taking C of S. Okay. So that's S plus 2. Okay. CSS plus 2 equals to R of S. Now divide both sides by um, S plus 2. S plus 2. So that's CS equals to R of S over S plus 2. And dividing both sides by RS. Okay. So basically, makancel si RS and mahimo na siyang G of S equal to 1 over S plus 2. Ano makancel man siya, miss? Now, dividing two fractions, di ba? RS over S plus 2 all over RS. Now, in dividing two fractions, okay, you get the reciprocal of the denominator and multiply it to our numerator. So, basically, ang reciprocal sa atong RS, di ba, kung alone na na siya invisible nga 1 nga denominator sa atong RS. So, that would be RS over S plus 2. You get the reciprocal of our main denominator. After getting the reciprocal, you multiply it with our numerator. So 1 over RS. Now you can cancel this one. So basically, ang mga bilhin is 1 over S plus 2. Okay. Muna siya, si GS equals 1 over S plus 2. Okay. In here, we need to find our system response. Okay. Now, since system response man siya, class, na nasa atong book, okay, if you recall, kung nakabasa mo, there are lots of responses there. We have the unit step, we have the ramp, we have the um, heavy side or any system response you have there. Akong try to pull up. Okay, try pull up. Okay, this one. Okay, this one. You have the impulse, the step, the ramp, the parabola, the sinusoid, and there are lots of inputs class in our system, and they have the function. Okay, delta t. We have u of t of t, 1/2 t squared u of t, the sine omega t. Okay, and these are their descriptions and are their also uses. So for that class, di ba na siya iyang what do you call this? Equivalent na form or Laplace transform, right? For our t of t or our for our delta t, okay, well, for our impulse we have 1 and unit we have our 1 over s and we have our um if I'm right, that's what do you call this? Uh ramp. So that's 1 over s squared and so on and so forth. We have also the sinusoid. Okay, we have the parabola. Okay, those are some inputs and their respective Laplace form. Now, for our example, we need to get a system to find the response CT to an input RT, which is equals to our U of t, our unit step, assuming zero initial conditions. To solve this, di ba naa natay given nga na-solve nga GS which is 1 over S plus 2. Okay? Now, given R of t is equals to over U of t, okay, which is in Laplace transform, that's R of S equals to 1 over S. That's the unit step. Okay, unit step. Di ba atong ramp is 1 over S squared, where impulse is just 1. So given GS equals CS over RS, which is equals to 1 over S plus 2, we need to get our CS first. Okay? Kaya itong aim here is our CT. Di ba itong ipangita is CT. To find the response CT to an output, RT, si RT is equals to over U of T. So, naman tayo given nga G of S equals CS over RS. We need to find CS. We need to have CS. Okay? Si CS ato ipagawa. So, basically, CS is just equal to G of S times R of S. Okay? Ini inverse Laplace na to ana, okay, this will become C of t equals to the product of over G of t and R of t. Okay, so s- okay, now over CS is um ewan ko ba masuot. Okay, 3 na lang B. So our GS class is 1 over S plus 2. When you multiply it with our RS, remember our RS is equals to our U of t nga atong gi-Laplace transform which is our unit step. The Laplace transform of our unit step is 1 over S. Okay? That's U of t man, di ba? And you get the Laplace transform, that's 1 over S. Kung mayroon ka o ramp, so that's T U of t. So basically, ang Laplace transform na is 1 over S squared. But in here, it's on unit step. So basically, we have 1 over S plus 2. Okay, that's our CS. Now, getting the um what do you call this? Getting the factors or the roots of this form, we can do partial fraction decomposition. Now in solving partial fraction decomposition, you can have our, di ba, ang form ani niya is nakaingon ani man A over S plus B over S plus 2. And given s- is after solving ha, uh, A is 1/2, dili na siya given, gisolve na siya kas, and our B is negative 1/2. So basically, our CS is in the form negative 1/2, rather, positive 1/2, wala lang na siya, over S minus minus 1/2 S plus 2. Okay. Now, after getting our final CS, then you take the inverse Laplace. So inverse Laplace of 1/2 S, 1/2 over S is just 1/2. Okay, minus the inverse Laplace of 1/2 over S plus 2 is just S 1/2 e raised to the power of negative 2t. One na siya iyahang inverse Laplace. And that's the system response for our CT with respect to our unit step. That's our CT. Nakasabot?
Yes, ma'am.
Okay. So for another example, example number 3, okay. Okay, that's the given. We need to find the equivalent transfer function corresponding to the differential equation d cubed c over dt cubed plus 3d squared c over dt squared plus 7 dc over dt plus 5c equal to d squared r over dt squared plus 4 dr over dt plus 3. Okay, that's the given differential equation. Okay, we need to find the transfer function g of s. Okay, now in getting the function g of s, we need to have cs over rs. Now, in order for us to have the cs over rs, we need to take the Laplace transform of our given differential equation. Okay, so for the Laplace transform of our d cube c, so we have s cube, so pi
CS Miss.
okay, cs, and then plus
CS squared CS
3s squared cs plus 7s cs plus 5 cs equal to s squared
squared
cs
CS
plus 4s cs cr rs there, sorry, rs plus 3rs. Okay, factoring out cs because it's common, so s cubed plus 3 mm, 3s squared plus 7s plus 5 equal to rs s squared plus 4s plus 3. Okay, now dividing both sides by s cubed. Kung ayaw mo ganahan mag-ratio, kaya maglibog mo, 7s plus 5. You can also do this one, s cubed plus 3s squared, s squared plus 7s plus 5. Okay, so mabilin si cs, okay, which is rs s squared plus 4s plus 3 and s cubed plus 3s squared plus 7s plus 5. Now we divide both sides by rs. Okay, so basically we have g s c s r s equal to s squared minus plus 4s plus 3 s cubed plus 3s squared plus 7s plus 5. So that's our g of s. Okay, now for example number 4, okay, we need to find, sorry, Okay, so for example number 4, we need to find the differential equation corresponding to the transfer function. GS 2s plus 1 over s squared plus 6x plus 2. Okay, that's our transfer function. Water break, sorry. You work in minute. Okay, going back. So if we have GS equal to 2s plus 1 over s squared plus 6s plus 2, now in getting the transfer function, and I mean getting the differential equation for this given transfer function class, we can get this form. Diba? Si GS is equal to over CS over RS. GS is equals to over CS over RS, which is basically equal to 2s plus 1 over s squared plus 6s plus 2. Now, cross multiplying that one, so we have CS s squared plus 6s plus 2 equal to RS 2s plus 1. Okay, distributing, we have s squared CS plus 6s CS plus 2CS equal to 2SRS plus RS. Now, taking the inverse Laplace, so that would be, since naka-second order man na siya, so D squared C, kaya naka-C of S ta, over dt, plus 6 first order dC over dt, plus 2C equal to, naka-first order gyapon siya, dr over dt plus r. Okay, and that is our answer. Oops.
Excuse me, ma'am. Hindi na dt squared, ma'am. Pinaka-left side.
Pinaka left side, dt squared, sorry. Hold on.
Thank you, ma'am.
Okay, thank you. Okay, so for another example number 5, ano na yung number there? So for number 5, sorry, we need to find the ramp response for a system whose transfer function is s over s plus 4, s plus 8. So given this one class, remember ramp response, okay? Our ramp response has a time domain form, which is t, u of t, and for the Laplace of that, that's 1 over s squared. Kung wa ako masayop. Okay, so that's s squared. Okay, so given our GS for this one, okay, we need to find our ramp response man. So that should be in a form C of t, but we don't have C of t in here yet. So we can make this CS over RS. Now cross multiplying this two, we have CS S plus 4 S plus 8 equal to RS S. Okay, 29 na mo. Okay. So in here, some lapis. So if we have our ramp input, which is 1 over s squared in Laplace form, so getting the GS multiplied by our RS, so definitely we can have this one. S over s squared, s plus 4, s plus 8. Okay, you can cancel the s, one of the s here, usan lang mabilin diha. So basically, we can have 1 over s, s plus 4, s plus 8. Okay, and we know what will happen. We can have 3 roots or 3 factors for this one. That would be um, a over s plus b over s plus 4 plus c over s plus 8. Okay, partial fraction differentiation. So we can have this whole equation multiplied by s, s plus 4, s plus 8. So this is 1 equal to a s plus 4, s plus 8 plus b s plus 8 plus c s plus 4. Okay. 1 equals a, by the way, s plus 4 and s plus 8 is s squared plus 12s plus 32. So this should be s squared plus 12s plus 32 plus bs squared plus 8bs, okay, plus cs squared plus 4cs. Okay, distributing, that's 1 equals as squared plus 12as plus 32a plus bs squared plus 8bs plus cs squared plus 4c5. Factoring out common, a plus b plus c. Okay, manatana plus s, which is 12a plus b 8b plus 4c plus 32a. Okay, evaluate. CS is 12a plus 8b plus 4c. And for our constant, that's 1 equals to 32a. Divide 32, divide 32. So we can have a equals to 1 over 32. Using our s squared equation, a plus b plus c. So I want to have a letter c. So that would be negative a minus b. And we already have our a, which is 1 over 32 minus b. So that's our So 0 equals to 12. 12a plus 8b plus 4. Our C is so 0, 12 over 32, 1232 divided by 4, 4, 3 over 8 um, plus 8b minus 4 over 32 divided by 4, that's 1 over 8, okay, minus 4b. Simplify. 3, 8 minus 1, 8, that's 2, 8 divided by 2 over 2, that's 1 fourth. And 8b, 4b, so that's positive 4b. So 4b equals negative 1 fourth divided by 4 divided by b equal to negative 1 over 16. That's our letter B. So we can have over C equal to negative 1 over 32 minus negative 1 over 16. C is negative 132 plus 1 over 16, which is 1 over 32. Okay. So our A is 1 over 32. So 1 over 32 S. Our B is negative 1 over 16. S plus 4. Our C is positive. So what's 1 over 32? S plus 8. So which is taking the inverse Laplace, C of t, that would be inverse Laplace of 1 over 32 S minus inverse Laplace of 1 over 16 S plus 4 plus inverse Laplace of 1 over 32 S plus 8. So this is 1 over 32 minus 1 over 32 e raised to the power of negative 40. 16 din ito. 16. 40 plus 1 over 32 e raised to the power of negative 8t. And that's our ramp response. Nagka-follow ra ba?
Ano ko'y question ba?
Yes, ma'am.
May question? Unsay question?
Karang sa baba man ba? Pwede pa scroll up gamay man. Kana dran PF is kanang dira sa una man ba? Before ta nag
Ni?
PF day. Oh.
Hmm. Ani?
Oh, hasta sa ubos ma'am.
Unsa?
Ay dili kotobra dira ang CS ma'am.
CS.
Kanang third line man ba sa first na kon. Kana
Kani?
dira utod. Oh. First to third line ma'am. Wala kay ko kasabot dira ulapit lang.
Okay. So, di ba natay given GS? Di ba? This is the given transfer function, which is GS S over S plus 4 S plus 8. Now, we need to have the response man. In response, it should be on C of t, form C of t in time domain. So since this is GS, C of t atong ipangita, that's the inverse Laplace of our C of S. So dapat naka CS over RS ta nga form, dili G of S. So since G of S equals CS over RS, we need to find CS. So gi-cross multiply na ko si CS. So that's CS lang equal to GS times RS. You cross multiply man here, you cross multiply sad GS of RS. Now CS equals GS, natay given nga GS, kopyahon nimo diri, i-multiply nimo ni RS. Given RS is the ramp response. Ramp response is this one over S squared. Okay? So atong i-multiply si GS ni RS, which is S over S plus 4 S plus 8 times ni 1 over S squared. So pag times nimo si numerator o si numerator, so S times 1, so that's S, muna siyang S diri. Makita ra akong cursor.
Yes, ma'am.
Okay, now this one, S plus 4, S plus 8 times S squared is S squared, S plus 4, S plus 8. Sila tulo kuyog. Now, pwede man nato makancel si S sa babaw, magkuha tag usa ka S sa atong S squared. Since si S gikuhaan diri usa, so 1 na lang na siya. Constant 1 because that's 1S. 'Di ba? Any alone nga mga variable na siya invisible 1 nga kuyog. Now this is S squared, gikuan man nato siya usa ka S, so that's just S. So basically 1 over S plus 4, S plus 8.
Okay, ma'am. Salamat, ma'am.
Okay. Do you have question?
Miss, kanang RS miss ba kay TUT gyud na siya?
Ramp man, ramp.
Okay. Naagi
Depende
na siya sa naagi na siya sa given miss.
wa na siya gihatag. Okay, gihatag na. Ang problem is you need to find the ramp response. Now, given sa katong mga table before, what's the ramp response? In time domain, that's T of T. But we are dealing with S here. So it should be on Laplace form. What's the Laplace transform of our TU of T? That's 1 over S squared.
Okay, ma'am.
Same ganina, unit step. Ang katong unit step, gihatag na to siya ganina, which is 1 over S. Si U of T is just equal to our RT, which is 1 over S unit step. So you solve. So this is the final answer.
Thank you, ma'am.
Kuha ra?
Ah.
Okay. Kakuha ra kas?
Yes, ma'am.
Okay. So for another topic, this is just the small discussion for our next topic. No, mo ra ni siya. Okay. And I will give some more example for our next meeting after intrams. Mhm. Where ah, okay. So this one, we are on electrical network transfer function. So in this section, we formally we formally apply the transfer function to the mathematical modeling of electric circuits, including passive networks. What are those passive networks? Capacitor, resistor, inductor. And operational amplifier circuits, puhon. Subsequent sections cover mechanical and electromechanical systems. So, yan na siyang mechanical, electromechanical. Equivalent circuits for the electric networks that we work with. The first consist of three passive linear components, resistors, capacitors, and inductors. So the table below summarizes the components and the relationships between the voltage and current and between voltage and charge under zero initial conditions. So if we have here a component capacitor, which is positive, negative, Okay? In voltage to current relationship class, V of t is equals to 1 over C integral of our IT dt. Okay? Ang kani siya class, that's tau. Okay? But some textbook, gibasa lang na siya og T. Okay? That's okay. And for our current to voltage, okay, for our current to voltage, we have I of t equal to C dVt over dt. And for our voltage to charge, so that's V of t equal to 1 over CQ of t. Okay. For our impedance, impedance class is just the same with resistance. But since we're dealing with higher tier of discussion, especially in amplifiers. So that's impedance. So that's PS over IS. In Laplace transform, so for our capacitor, that's 1 over CS. Then the reciprocal of our impedance is our admittance. So that's 1 over S, or 1 IS equals to VS. Okay, that's YS class. Muna siya ay denotation always sa admittance. Y. For impedance, that's Z. So you take the reciprocal of the impedance. Our impedance for capacitor is 1 over CS. So the admittance is CS. Now, for our resistor, for our voltage current relationship, we have V of t is equals to our I of t. That's just Ohm's law. Okay, resistor R and current IT flowing throughout the um, circuit. For our current to voltage, so that's IT equals to 1 over R VT, or V over R, VT over R. In voltage charge, so that's R dq of t over dt, the differential of our charge with respect to t. And for our impedance, that's just R. And our admittance is 1 over R, which is our conductance. So for our inductor class, so V of t is equals to L differential of our current with respect to t, IT dt. And for current to voltage relationship, that's I t equals to 1 over L integral of our VT dt. For our voltage to charge, that's V of t equals D, second derivative of our Q of t with respect to t. And for our impedance, it's just LS. And for the admittance, reciprocal of LS is 1 over LS. Okay, so that's the okay. Okay, so that's the relationship, okay, for our electrical network transfer function. Okay, kani siya class, gamit ni siya if we are solving, if we, for example, we are solving RL networks or RL circuit networks. We have RC, okay, we have RLC, the combination of the three. Okay, so for example, if we are given, oops. So if we are given, so okay, so if we have IT flowing here and we have our L, okay, and we take the output opposite, okay, across rather, across our L. So this is our V of t, okay, and this one here is our VI of the input and output. Now, if we take the output across our L, so that's V of t equal to, what's our L? Yes, in terms of voltage. Okay, here, that's L di dt. Okay, now taking the Laplace transform of this one class, it's just here in the impedance, looking at here. So that's just Ls I of S. Since naka-S man ta, sumpayan dyan na siya nimo og S. Di ba class, if we are dealing with differentials, naka-S man na siya. And since this is on incurrent, okay, so that's I of S. LS, IS. L, this is S, and ihang sumpa I of S. Okay, that's the um, form for our V of, since this is input, so ang output na nato is LS I of S. Okay, taking the impedance, okay, taking the impedance class. So that's just LS. Okay, si impedance ang atong kuha diri. Okay, but if we are going to get the voltage output, it's just the LSIS. Okay, because voltage is the impedance or resistance times the current. And our impedance for in terms of our inductor is LS. Okay, times our IS, that's our voltage. Okay, if we have a certain um, capacitor, okay, an IT is showing here. So if we have capacitor C, okay, and we measure the output voltage across this capacitor, okay, so we have V of E equal to what's our capacitor? So that's 1 over C. 1 over C integral of IT dt. You can neglect for now the 0 and the 1. It's just the limit. Okay. So V of S, pwede na wala na na output. Okay, V of, tama ba yun? So the V of S is just 1 over the integral of our um 1 dt, okay, is 1 over S. Okay, we need to compensate over S. So mahimo na siyang CS. Ato lang ko ng SB. So times 1 over S IS. Okay, so V of S 1 over CS IS integral of dt. 1 dt is just 1 over S. Okay. Integral of 1 dt is 1 t. So that's 1. So 1 over S na siya in Laplace form. So here, taking the impedance is voltage over current. So it's just 1 over CS. Okay, that one. For the next one, if we have a resistor R, a capacitor C, given V, okay, voltage input, okay, and if we take the output voltage across our capacitor, okay, this is our R, this is our C. Okay, so you do the looping. Okay, if we have IT here, okay, if we have IT, so V of T, okay, so R, what's our R here? Ano ko ba yung- R, I of T. Okay, this one here, Ri of t. So this is Ri of t plus the capacitor 1 over C integral of I t dt. Okay, so V out, and you take the loop for our V out here during a part. So V out is just 1 over C, sorry, integral of IT dt. We make a loop here, we'll also make a loop here. Okay, so that's just 1 over C IT dt. Even if you make a loop here, it's the same man class because usa ra man ang iyang padulngan. It's just the capacitor. Okay, so getting the Laplace transform of our input and output. So for our input, so that's S, which is R I S plus 1 over C S I S. And for our V output, it's just 1 over C S I O S. Okay, now for in here, we can factor out IS, which is common. So it's R plus 1 over CS. Right. Now taking as our definition of our transfer function, okay, transfer function atong pahitaon, it's the ratio of our output to input. Okay, so output VOS over input VI of S. So this is 1 over CSIS all over atong VS, which is IS R plus 1 over CS. Kuhaan mo si IS. So basically, we have 1 over CS all over R plus 1 over CS. Okay, now if we want to make it simple, okay, so CC R over CS class 1 over CS. We can simplify this form. You take the LCD, which is CS. So CS divided by 1 is CS times R. So that's RCS plus 1 because CS divided by CS is 1. U times with 1, so that's 1. Okay, now dividing two fractions, you take the reciprocal of the denominator, okay, denominator of fraction, and then you multiply it with our first or our numerator. So 1 over CS, so that's CS over, this is the reciprocal, plus 1. You get the CS. So basically, we have 1 over RCS plus 1. This is our transfer function. Naka-follow ra mo, class? Ouch.
Yes, ma'am.
How about the others?
Alam na, miss.
The-follow ra. Okay, how about we take the output across our resistor? Okay, unsay kalahian? In here, we take our output. Okay, we take our output. Ano naman eh? Okay, across our capacitor. How about we take our output across our resistor? So if we have, okay, So this is our C, this is our R. So this would be our input. Okay, you make a loop. IT, nagkurente ni agi diha. So VIT input equals to our capacitor, which is 1 over C integral of IT dt, plus our R, which is RI of t. Okay, atong output. Ang nasa tong output, across sa tong output is just the resistor. So that's RI of t. And getting the Laplace transform of these two voltages. So VI of S is just 1 over CS IS plus RIS. For our output, it's just RI of S. Now, taking the ratio of these two, so VO input, so RIS, and for our VIS is 1 over CS plus RIS. Oops. Okay. You cancel out IS. So basically we have the transfer function R over uh 1 over CS plus R. And this is our function. Hey, kopyara? Hello.
Yes, miss.
Okay. So we have here, um, for example, class, if we have to seek the transfer function in terms of our IS over VS, so basically class, imo ra siyang IS over VS. So if you are, for example, uh, kani, you are given, no, naglag na. Okay. So given na nato si output ug si input, yan gi pangita sa problem is the ratio of our IS over VS. Di ba naaman tay IS, right? In terms of 1 plus RCS, 1 R plus, naglibog na. Okay. So IS in terms of this one is ISR plus 1 over CS. In here is 1 over SIS. So if you take the IS over VIS input, okay, current over the input in Laplace form, dahan po. Okay. Oh, okay. Okay. So from this part, Okay. So for this part, so IS over VS using this one. So IS over VS, imong kuhaon si R plus 1 over CS here. Okay, you divide with the V of VI of S here. Okay, ano lang isulat P? Okay, cancel here. So basically, mahabilin si, dili na ako butang kadagang space. Ah, balik. Okay, equal to IS. Now we need to get the VIS here. You divide both sides by VI of S, VI of S. So makancel si VI of S because the moment you take the reciprocal of VI of S is 1 over VI of S. And if you multiply for our fraction here, makancel si VI of S, which is basically equal to um, R plus 1 over CS. Okay? Ka-follow ra class? Ka-follow ra mo class? Wala.
Follow ra, miss.
Yeah, miss.
Okay. So let's do, since RC pa man na siya, let's do RL. Okay, resistor inductor. So if we have a given simple circuit here, resistor, and then some inductor, and we take the output across our inductor. Okay, so for this one, we have L, we have R, we have VI of S. T rather. So VI of T equal to R I of T plus L D ano sa L gani? DV. DVT over DT. Sakto ba? Okay. Okay. Equal to our output. Okay. LDVDT na siya class because it is on in terms of our voltage. We are taking the voltage output across our inductor. So in here, di ba nakabutang diri is um, L DIDT and VT. If we take the integral of our DIDT here, it's IT dt. And since you have L here, so that's 1 over L. Then the integral of our VT here is just the integral of VT dt. So if we do the in voltage form class, so you take the integral of our VT dt, so that's just dV dt over dt, okay? Sama na ni siya, L dV dt. We just need to review our differential and integral nga calculus. So if we have L dV of d over dt, So you take the inverse Laplace, which is R IS plus LS IS. Oops. Anaw na lang sa kunibi. Para di mo maglaybog. Maghihapon kay differential maghihapon siya. It's basically the same. Moingon kita og inductor class. 'Di ba akong gisuot kanina is in terms of voltage. And when we say capacitor, that's in terms in here. Let's get back here. 'Di ba? In terms of capacitor, okay, it's on resistance form. Okay? In terms of um resistance, so that's resistance gihapon R, 'di ba, V equals IR. In here, if we take the Ohm's law, that's R and I. Now in here, for our capacitor, if we take the Ohm's law class, CC is naka-form of 1 over C. It's in terms of our resistance because charge man na siya. And our I in here is integral lang na siya because we have changes in our if we have change in our current, so that's the integral. Now for our VT, if you can see here, for our VT LDI, okay, 15 minutes. Okay, so LDI it's still in form of our L and our DT. But looking at here, class, okay, in here, from I DT, dapat naka-charge. Ah, chill lang.
Dinner, 6 p.m., 6 to 8. Kamon doon,
Hmm.
6 to 8 p.m. Ceviche mo mantas.
Ay, dinner na, sir, no? Nakuno na ba kay lunch? Dili lang, sir. 4 ang kakotabron. Okay. So, in here, ang atuang gikuha class is output voltage across our across our inductance. So, dapat naka-voltage siya. So, from our voltage to current relationship, that's LDI/dt. So, let's do it on voltage. Okay? So, LD squared dt over dt squared. But, with regards to our L class, dili na siya naka-square. Okay? It's only on first order. Okay, let's just do it this way para di mo maglibog. Okay, so para i-derive sa aton di dt, I na lang diretso. LSIS. Okay, you take the Laplace of our output. So that's LSIS. Okay, so dili na lang ko ibutang. Factor out IS R plus LS. Okay, now taking the transfer function, output over input. Okay, output is L S I of S over R plus LS. Oops, IS. So that's LS over R plus LS. Okay, if we take the output voltage across our inductor. Okay. If we take the output across our nakahatag na ba akong resistor? If we take the output across our resistor class, so meaning ang atong out so if we take in that way guys, so making a loop, so Vi of t equal to what's our L? Okay, so that's L uh, plus our resistor. Okay, V output is R I T. Okay, taking the Laplace. So that's LSIS plus RIS. So V of S equal to RI of S. Okay, so getting the output over input. So V of S. Okay, RIS over L. Okay, that's how you find the output across our resistor. So far, nakapalo ra ba? Yes? Hello, are you still there?
Kuha
Yes,
ra,
ma'am.
miss.
Okay. Oops. Okay, so since we are done with RC and RL, okay, let's try to move on. Let's try to move on. Let's try to go on with RLC network. Okay, for our RLC network, okay, so for RLC network, if we have a given network here, okay, and we have IT flowing. So, okay, so if we have, this is the input. Inputan na to, this is V of T. Okay, and this is the output taking in terms of our across our capacitor. Okay, so that's ato siyang gipangalan VC of T. Okay, because we are taking the output across our capacitor. Okay, so that's V of T equals to our L. So that's dLd I T over dt plus our I, Ri of t, and we have our resistor. Okay, we have our resistor, I mean capacitor 1 over C. integral of IT dt. Okay, now if we make it on this form class, or if we write it on this form, ang atong dapat makuha is in terms of VC of T. Naka-voltage siya. But looking at here, ang atong mga terms is on current. So we have to make it voltages, sila tanan. So this is voltage to current. So from voltage, dapat may ato siyang ipaagi og charge. Kaya in charge, naman siya voltahe, voltage. And in terms of our charge class, pwede na ito makuha si VT. Ato lang siya ilisan o V of T para makuha na ito si VT. So in here, if we have V of T, okay, ako lang sa ning tabunan. Okay, in here, so our inductor from our LDIDT to make it on voltage to current and voltage to charge. Okay, so this one is L, okay, D squared Q of T dt squared. So atong R, okay, R dq of T over dt. Okay, and our C is just 1 over C. Okay, our atong IT dt class. Okay, atong IT dt, the it is equivalent to our dqt over dt from our current to charge. Okay, so our IT dt is equal to our I gets na. Okay, so if we have IT is the differential of QT over DT, so if we integrate this two, so makakuha tag QT equal to IT DT. So basically, this IT DT here is just equal to our QT. So naka-charge na sila tanan, right? Now remember, with the use of mouse, okay, with the help of this one, okay, muna atong aim, V of T equal to 1 over C Q of T. Okay, we need to find Q of T. Kani silang Q of T tanan ato na kuhaon. Okay, so V of T equals to L. Okay, on na to diri. 1, let's find Q of T. Q of T divided by 1 over C tanan. So this is basically C V of T. But since nakapacitor man ni siya, so that's C in terms of the capacitor nga atong component. So that's C VC of T. So this is C VC of T. T but since we have 1 over C here, okay, makancel na si C. For our R, okay, we have our R. This is our QT and naka-differentiate na siya. So that's RC. Since naka-differential na siya, so that's DV C of t over dt. So our L, since naa siya C here, so that's LC. Naka-differentiate siya, second order. So that's d VCT dt squared. Okay? Isulat na to balik. LC d squared VC of t dt squared plus RC dVCT over dt plus VC of t. VC of t na lang na siya kay naaman siya ay 1 over c niya. Gimultiply sa c, so that's 1. Okay, they are all in voltage form. So in getting the Laplace transform, so that's V of S equals LC S, since this is on square, so square VC of S plus RC S, ano man eh, VC of S, and we have VC of S. You factor out VC of S, so LCS squared plus RCS plus 1. Okay, now from the output, our input, we have our output which is on VC and our input on VT, VC of T and VT. Now taking the Laplace of this one, this is VC of S and this is VS. So basically our transfer function is VC of S divided by VS. Okay, so our transfer function, VC of S over VS. Okay, so you divide both of the equation by else. Okay, going back. So we need to have VC of S over VS over V of S. So we need to still divide overall both sides with V of S. V of S. So if you reciprocate this V of S, mahimo na siyang 1 over VS. Since 4 over VS, it times sa VS over LC S squared plus RCS plus 1. So makancel out si VS. So basically, ang atong transfer function is just equal to 1 over LC S squared plus RCS plus 1. Copy ra class? Hello?
Yes, miss.
Okay. And diha ra ko to akong discussion sa inyo ron. Akong next discussion will be on after intrams na. Okay? So, ako ra na i-send sa inyo, huh? Do you have any questions before we leave in this room? Yes? Do you
Wala
have
na,
any?
miss.
Wala ra.
Wala
Okay.
man ka, ma'am. Salamat, ma'am.
You're welcome. Okay. Export sa nila ko. Okay. Yan na class. So ako lang ni-send sa inyo ha. So if you don't have any questions, you can take your lunch. You can leave the room now. Thank you for the attendance. Bye. Bye, bye, bye.
Bye, miss. Thank you, miss. God bless
Bye,
po.
miss.
Bye, 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 bye.